Hello everyone, welcome to this video, which will introduce you briefly the Feng Institute's tech tree project. Feng Institute tech tree have 5 different tech trees. This video is going to introduce you the nanotechnology tree, or particularly molecular machine technology tree. So here is how it looks like. You can see I am using the Google drawing file because we actually have 7 contributors to this tech tree from 5 different countries. I have already downloaded this tech tree in a PDF file so that I can zoom in and zoom out to show you some detail of our trees. And here it is. And at the beginning, I would like to introduce our tech tree members. Here you are. So my name is Yuanning Feng. I'm a postdoctoral research fellow at Northwestern University in the United States, working on the design and synthesis of mechanical interlocked molecules-based artificial molecular pumps. As a tech tree leader, here's my contact. If you want to join us as a team members, feel free to send an email. We also have other wonderful team members. First of all, we have Izabela Judasvik. She is a research assistant at the University of Zagreb in Croatia, currently working on the synthesis of novel nanoparticles for energy harvesting. We also have Zach Wintrust. He is a chemical engineer living in Raleigh, North Carolina, the United States. We have Mark Overley. He is a PhD student at the University of Groningen, the Netherlands, working in light-responsive materials. And Christoph Lee. He is a graduate student at the University of New South Wales in Sydney, Australia, focusing on artificial molecular pumps for the creation of mechanically interlocked molecules. We also have Alexandru Lucateli. He is a master's degree student in biomedical engineering at Politecnico di Milano in Italy, specializing on nanotechnologies. Finally, we have Kunyu Wang. He is a PhD candidate at Texas A&M University in the United States, focusing on the design and synthesis of hierarchically porous framework materials. Okay, after acknowledging all my team members, let's come to see our tech tree. The body of the tech tree is located in the left-hand side. As you can see, there are, I think, roughly over 100 nodes. All those nodes are linked by the arrows, which indicate the relationship between tech trees. We also divide those nodes into 4 columns, which is the 4 layers of the tree. From left to right are general topics, specific categories, particular things, and potential applications. General topics are the textbook example of the research area. For the sub-area of general topic, we can see polymer chemistry, organic chemistry, physical chemistry, and so on. When we come to the specific categories, you can see some detail when you want to search or make a molecular machine. For example, building block is very important for the design and synthesis of molecular machines. It needs the knowledge from polymer chemistry and organic chemistry. Let's move into the 3rd column, so-called particular things. Those are actually real particular things. You can see catenins, rotaxins, cyclodextrin, chrome ether. Those are something you can really see that in a particular research project. Catenin can even identify by polycatenin, and rotaxin can also be a polyrotaxin. And in order to make polyrotaxin, you may think about, use a polyrotaxin synthesizer. That's actually a science paper published in 2020. There are also many other components, design mechanism, and other keywords that is showing a particular thing in the field of molecular machine. You may find out some of the nodes are colored in a shade. Those are the potential challenge we are consider in the field of molecular machines. We may ask ourselves some question. Will this challenge be achieved in the future? That could be a very interesting goal for the researchers in this field. Okay, let's move to the right-hand side of this tech tree. We can see there are two columns under the linked references, including books or reviews and communication or articles. They all contain those notes-like links. You can always click one of the links that include the title and the journal, and you can read those review articles easily by clicking one of the links. Coming back to the tech tree, you can also find out some research articles by clicking the links of this communication and article links. For example, you can click the precise polycrystalline synthesizer, and it directs to one of our science paper published in 2020, and you can read in detail. You might need the access for this scientific journal. We don't have the PDF file in order to not have a copyright issues, but you can always click this link. They are very useful. At the very bottom right corner, we have the link to the subnodes. We already have 6 subnodes, and each subnode can click you into a new area, which actually show you a brief introduction of this subnode. For example, here's an azobenzene application subnode. Those subnodes are also very useful if you want to look in depth for the particular molecules, building block, or molecular machines. We are still building those subnodes right now. Okay, that's an overview for the zoom out of this tech tree. You may find out there are lots of contents in the tech tree and they all link together. But why this tech tree is useful? I am also questioning myself why I'm making this tech tree. The reason I think is that it gives you a graphical representation of the development of this research field, which I love this field, medical machines. If you are a scientist or engineer not in this research field, or you may even a junior student or public audience to want to learn this field, you may not need to read those literatures published in scientific journal. You just have a look at this tech tree, and you know this is digital. You can always use the search function in a digital PDF file or Google Drawing file easily. For example, I have already typed in motor for you, and you find out, oh, there are 38 motors embedded in that tech tree. And you can go over to find out where it is. You can also find some literatures that containing motors in their title, so you can click in to find out more details of the development or research project of the motors. That's how the tech tree works. It's interactive, it's brief, and it's also fast to help you to find out the relationship of those particular things, potential application, specific categories, and general topic. So I really hope you enjoy this tech tree and hope you can contribute to the tech tree if you have any idea. Just feel free to contact me. Thank you very much.